Hey guys, welcome to 9.4 volume of prisms and cylinders. So in this first example, it says find the surface area of this solid. And we've done surface area before. Remember, surface area is our lateral area plus 2 base areas. And lateral area is the perimeter times the height of the prism plus 2 base areas. Now, if we look, we have a rectangular prism. It does not matter what we call the base. I'm just going to say, let's call this one the base. So the perimeter of the base here, we are going to have 4 plus 2 plus 4 plus 2. So we have 12 times the height, which is 6. And remember, height is distance from base to base. All right, plus 2 times the base areas. And our base is a rectangle, so we're going to take 4 times 2. Okay, so if we do that, 12 times 6 gives us 72. Here we get 8, and 2 times 8 gives us 16. So if we add that, we get 88, and this is going to be centimeters, or units, sorry, units squared. So that's our surface area. That's just talking about on the outside area. Now, when we are talking about volume, we want to know how many individual cubes do we have. So surface area, I'm counting each of these sides. So we counted that one, and we count this one, and this one, and here. So that surface area is counting each individual one. When we're talking about volume, here, now we're counting, this is 1 square, or 1 cube. So we're counting the whole cube. When we're counting surface area, we're just counting each individual side of the cubes that are exposed. So if I'm counting the number of cubes, and I'm just going to erase what I was writing so we can see. So I'm going to count cubes. So here's 1 cube, 2, 3, 4, 5, 6, 7. So this is 7, 8, 9, 10, 11, 12. There's 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So we can only see 33, but we have to keep in mind that in these 2 rows, and then or actually these 3 rows, there are ones that we can't see. So we really can't count them all just from the picture. So, but volume, you guys have talked about volume before. Base times height times length. So 6 times 4 times 2. So if you type that in your calculator here, there should be 48 units cubed. All right, so we counted almost all of them. There was 15 that we couldn't see. All right, so let's move on, excuse me, to volume of a prism and volume of a cylinder. Excuse me. So volume of a prism is going to be the base area times the height. So we find the area of one of the bases and we times it by the height because that's how many there are. Now in a cylinder, it's the same thing, the base area times the height, but because our base is always a circle, instead of putting base area, we can replace that with the area formula for a circle. And the area formula for a circle, remember, pi r squared. And then we're going to times it by the height. Right, so take a moment, make sure you get both of those down. Now, those are given to us, well, this one is given to us on the MCA sheet, and we are given the area formula for a circle on the MCA sheet also. All right, so let's get into a few problems. So we have a triangular prism here because my bases are triangles. So we're going to find the volume by finding the base area, and we're going to times it by the height. Now remember, height is the distance between the 2 bases. So if I have a triangle, the area formula for a triangle is base of the triangle times height of the triangle divided by 2. or you could say 1/2 base times height. So I'm going to do base of the triangle and the height of the triangle and divide by 2. And I'm going to times it by the height of the prism. So distance between the bases times 11. All right, 10 times 12, we get 120. And when we are going to divide by 2, and when we divide by 2, that gets us 60. And we're going to times that by 11. And that turns into 660 centimeters cubed for our volume. That one was pretty nice. So let's look at the next problem. And in the next problem, we have another triangular prism. My base is a triangle, but this time they give me my base of the triangle is 9, but we have this 15 back here, and that's the hypotenuse length here. So we need to be able to find the height. So if it's a right triangle, we're going to use Pythagorean theorem to help us find the height. So I'm going to take 15 squared, and I'm going to subtract 9 squared from it, and then take the square root of that. Did you get 12? I hope so. So my height is 12. Now that's the height of my base, not the height of my prism. Remember, the height of the prism is the distance between the two bases. So let's go ahead and put this into our formula. So it's a triangle, so we're going to do base of the triangle, which is 9, times the height of the triangle, which is 12, and we're going to divide it by 2, and then you times that by the height of the prism, so distance between the two bases, which is 10. So grab those calculators, and I know that you guys have some fast fingers here. Take 9 times 12, we get 108, and then we're going to divide that by 2, and you get 54. And then I want you to times that by 10, and we get 540 feet cubed. All right, so this next problem, we are actually, I'm going to have you guys skip it because it's at that pentagon base again, and we haven't practiced finding the area of those. So remember what we talked about for those, just skip that. Let's go to the next page, and you have a cylinder. So remember, cylinder one volume formulas include pi r squared. So my base is pi times my radius of 3 squared times the height or the distance between the two bases, which is 8. And we can just type that straight into our calculator, and you don't really have to do much work for that one. And if you type that in, and remember, let's use the pi button on our calculator, we get 226.2 centimeters cubed. All right, we have another prism here that is a cylinder. Now the thing about this cylinder is that we don't have our distance between the two bases. What we do have, though, is this diagonal, and we have this height of the base as 10. So what I see here to find this distance is a right triangle. And so we're going to find x. So my legs are x squared plus 10 squared equals 16 squared. So go ahead and take your 16 squared and minus 10 squared from it. And then take the square root of that. And we're going to find the distance between the two bases is 12.5 when we round it. So volume of the base, pi, times my radius. Now my radius isn't 10, that's my diameter, that's the whole distance. My radius is only half of that, squared, times that 12.5 that we found. So just type that into your calculator. Pi times 5 squared times 12.5. And for our volume, we get 981.7 centimeters cubed when we round it. Okay, let's try one that doesn't, that's an oblique, oh yes, hexagon. Okay, sorry, it took me a moment because I'm like, oh, we haven't practiced writing hexagons and finding the area, but they give us the base area, so we don't have to worry about that. So this one is almost easier than you think. The volume, remember, is the base area times the height, which is the distance between the two bases. Oh goodness, they give us that too. So 17.3 times 6.4 could not be easier. They tell us both of the things we need. Did you do it in your calculator? You should get 110.7. It was 7.2, but we can just round to one decimal place. Centimeters cubed. Okay, so here we have this next problem, and it says prisms A and B have the same length and the same width, but different heights. If the volume of prism B is 150 inches greater or cubed greater than the volume of prism A, what's the length of each prism? Okay, ooh, that sounds like a lot, doesn't it? So prism A, to find the volume, we have base area times height. Okay, so my base area is going to be the 4 times the 7 and times the height. Prism B, well, I should do volume A, volume B has 4 times 10 for this one times the height, okay? Or I should say length, because they have the same length. So those numbers, those H's, are going to be the same in Prism A and in Prism B. I actually think I need a little bit more space to do this. Just give me a moment. Okay, magic, more volume or more space. So it says that prism, if the volume of prism B is 150 inches greater than the volume of prism A. So the volume of prism B is 150 inches greater than the volume for prism A. So now we're going to plug these values into that one above. So I'm going to multiply 4 times 10, and I get 40 times the height, so that's my volume of prism B, equals the volume of prism A. So 4 times 7 gives me 28 H, that's volume of A, plus 150. So next, I need to get the H's to the same side. So I'm going to subtract 28H on both sides. And that gives me 12H equals 150. And I can divide both sides by 12. So 150 divide by 12. And I find that the H, the length or the height in both prisms is 12.5. So if I was to plug 12.5 back in for these H's, I would find my volume of prism B to be 150 inches cubed larger. All right, there we have it, ladies and gentlemen. Then you're going to go ahead and jump to your worksheet, and you will be able to do all of those problems on the worksheet for us today. See you guys.